For number 14, you can use that information to help you. It says we're crossing a white-eyed female with a red-eyed male. Remember, females are XX, males are XY. So if she's white-eyed, she has 2 lowercase r's attached to her X chromosomes. The male, because he's red, has a capital R attached to his X chromosome. So when we do the cross, we end up with 50% red-eyed females. So we found XX with a capital R. We have 0% red-eyed males because our 2 males have the lowercase r's. We have 0% white-eyed females because none of our females are XX with little r. And we have 50% white-eyed males because both of our males are X with the little ry. They get that trait from their mother's X chromosome. In 15, same idea as what you just did, except now with hemophilia. Females can be normal, X with a capital H, carriers, or have the disease. Notice if they have the disease, it's lowercase h's, so it's a recessive trait. So we show a cross with a female, XX, who carries the trait, so she has a capital H and a lowercase h, with a man who has the disease. So he is a man, XY, who has the disease, which is recessive. We complete the cross. Notice you have 50% females, 50% males. And the question asks, what is the probability that their children will have the disease? Out of all 4 boxes, 2 of them have the recessive trait. One of them is a female, one of them is a male. So there's a 50% probability that they will have a baby that has the hemophilia disease. 16 is a dihybrid cross. We know that the first step with our dihybrid cross is to find the gametes. We have to do FOIL. So it tells us that the male rabbit is capital G, lowercase b. He can only give one different combination of big G, little b. Whereas the female rabbit, it tells us is little g, big B, little b. So she has a couple combinations. She could give a little g, big B, or a little g, little b. And she does that twice. If you set up your gametes wrong, then your Punnett square is going to have the wrong information inside of it. So you want to make sure that you copy your gametes perfectly onto your Punnett square. When you do this, you actually end up with rows that are the same. That's why I drew the arrow across instead of rewriting them. They're the same because if you notice, the gamete along the top doesn't change. So it's always going to be the same combination across. For the gamete down the side, you have to see if that changes the different genotypes. The question asks us to count. So for gray hair, black eyes, we're looking for a dominant trait and a dominant trait. Gray hair, red eyes, dominant trait with the recessive B's. White hair, black eyes, white hair is recessive, so we're looking for little g's with a capital B for the black eye. And white hair and red eye is all recessive. When you do the cross, you have 8 that are big G, big B, little b, which is gray hair and black eyes. You also have 8 for gray hair and red eyes, big G, little b, little b. 8 plus 8 is 16, so you have 0 for the other 2 options. There are no little g, big B, and there are no all recessive.